All right. Title's changed up. I'm just going to put the title card on there for a second. And away we go. Hello? There's no sound here. Is there? Did I? Like here, sound check it. RimWorld. Yep. Yeah. You guys understand the reason why I put the measuring system in feet and miles is to piss people off, right? Look what it's doing. Looks like I'm succeeding. I'll be right back 1 second. I'm going to take a piss real quick. Some men just want to watch the world burn. Give me 1 second. Yeah, Erudite, they're probably waiting for NASA, dude. If I had to guess. Did you use the smoke or what's the deal with the toothpicks? My mother-in-law bought them for me, and yeah, I like them. That's the deal. I think I'm gonna finish this last pack of them and then just be done. I don't need this. I got a case. Somebody... Fish, I went to the P.O. box yesterday. It's a freaking case full of Red Bull in my P.O. box. So I have a case of Red Bull now, like... I think between the toothpicks, Red Bull, and coffee, I should probably stop. Like, I am not. I think I've OD'd on caffeine probably like the last 3 or 4 days in a row. I know I can't drink too much Red Bull. Doctor said don't do that. Or you'll be strunking the bondulins, you know what I mean? You know, we should do that. That's good. There we go.
Discovery, go and throttle up.
Falcon 9 is in startup.
That's the wrong pad. Hey, Beazle, 37 months. Hey, August.
Go for launch.
Wicked. All right, CRS-30 coverage. Let's do this. This is a great
go and
intro.
throttle up.
And there he is. Oh, that's killer. Commercial resupply services 30.
You're looking at a live view of Falcon 9 and Dragon awaiting liftoff from Space Launch Complex 40, or Slick 40, at Cape Canaveral Space Force Station in Florida. In just over 19 minutes, Falcon 9 will lift off carrying Dragon and the CRS-30 mission to the International Space Station. Good afternoon, I'm Yomei Zhou, a propulsion engineer here at SpaceX in Hawthorne, California. Dragon will deliver about 6,200 pounds of science, supplies,
How's
and
the audio
equipment
balance
to the
with my
space
mic?
station
Good?
and will return
Good,
with
bad?
about 4,000 pounds in just about a month. Dragon will arrive at the space station and dock autonomously to the zenith port of the station's Harmony module on Saturday. For those of you following along, you'll
Good.
note that
All right,
this
cool.
mission marks our 27th of the year and our 42nd Dragon mission to the station. It's also Dragon's third trip to the station this year, and it's only March. Today is the first time our upgraded Dragon spacecraft will be launching from Slick 40 after we stopped flying our previous version of Dragon back in 2020. To support our growing launch manifest, we've made new upgrades to Space Launch Complex 40, including a brand new tower and access arm, which enables more efficient late load operations as well as human spaceflight missions. The new crew arm allows Dragon flexibility to switch between pads LC-39A and Slick 40 for
go
all
and throttle up.
missions.
Yeah, boy.
In addition to the crew access arm, the teams have recently added 2 emergency egress chutes to provide
Hit the
an
plop.
additional way to rapidly evacuate the tower. Teams tested the new emergency chutes for the first time earlier this month. With these updates, we're on our way to having 2 launch pads capable of supporting flying humans to space. We'll have more exciting human spaceflight updates to share a little later in the program. Dragon is the only vehicle flying today that can fly a round trip to and from the space station, carrying vital supplies to space and returning safely with critical cargo. Today's Dragon spacecraft will be flying for the 4th time, and the Falcon 9 it's sitting on top of will be making its 6th flight. Reusability is key to everything we do here at SpaceX, and to date, we've reflown 24 Dragon spacecraft and 241 Falcon 9 rockets. Speaking of Falcon 9, propellant loading began about 15 minutes ago and will complete at the T-minus 2-minute mark. Weather is looking great with only a 10% probability of violation.
Discovery, go and throttle
Range
up.
is green and ready to support. Everything is looking good as we count down to an instantaneous launch attempt at 4:55 p.m. Eastern Time today. And with that, let's check in with Gary Jordan at NASA in Houston.
Gary?
Hey, Yome, it is great to be with you. I'm here at NASA's Mission Control Center in Houston, Texas, where flight controllers are looking after the orbital laboratory that is the ultimate destination after Dragon's launch today, the International Space Station. We're watching today's launch closely and working with the teams with you there in Hawthorne, California, as well as Falcon 9 teams at Kennedy's Space Center in Florida, following the launch criteria. As of this moment, the teams here in Mission Control Houston are go for launch. The International Space Station is ready to receive Dragon and the 3 tons of cargo on board. You'll see 2 flight directors in Houston today. There on screen is Flight Director Diane Daly and Nicole McElroy. Lots going on in this room and aboard the International Space Station today, and teams are following along in the action. Just this morning, the scheduled launch of the Soyuz MS-25 was automatically scrubbed by ground support equipment due to a low voltage reading in the Soyuz rocket electrical system at the Baikonur Cosmodrome in Kazakhstan. NASA astronaut Tracy Dyson, with her counterparts, Soyuz Commander Oleg Novitsky, and spaceflight participant Marina Vasilevskaya, have since safely egressed or exited the Soyuz spacecraft and left the launch pad, and are safely back at the Cosmonaut Hotel crew quarters as teams evaluate another launch attempt. Meanwhile, here in Houston, teams shift focus to watch the countdown towards the launch of Dragon on top of Falcon 9 for NASA's SpaceX 30th Commercial Resupply Services mission. To dive a little deeper into the vehicles of this launch, I'll turn it back over to Yome in Hawthorne. Yome.
As we continue to count down, let's take a closer look at the vehicles that will be taking CRS-30 to the space station today. Sitting atop the Falcon 9, the Dragon spacecraft and its trunk stand over 26 feet tall. The nose cone opens shortly after launch to expose the forward bulkhead thrusters and docking mechanism that will connect with the station. Dragon is headed for the Zenith docking port on the station, which was just vacated by Crew 7, which came home last week. Dragon's trunk holds solar cells, which power Dragon while it's in free flight. The trunk can also carry unpressurized cargo, which it will be doing today. Dragon has 16 thrusters that can be used in space to help navigate the spacecraft to its destination, with each thruster providing about 90 pounds of force. The Dragon spacecraft has played a significant role in advancing our future in space by safely transporting crew and cargo to and from the space station. There are currently 4 Dragon spacecraft supporting human spaceflight missions that have docked to the station, and their names are Endeavour, Resilience, Endurance, and Freedom. There are an additional 3 Dragon spacecraft supporting cargo missions. Altogether, the reusable Dragon spacecraft fleet has completed 8 human spaceflight missions on behalf of NASA and has both visited the station and returned to Earth 41 times under NASA's commercial resupply and commercial crew programs.
I just want to point out that they cut the camera right when I wanted to point that out. That camera angle from the crew access arm looking at Dragon, we've never seen that before. I think that's the first time they've used this. If I'm misremembering, if I'm misunderestimating, let me know. But I don't remember ever being able to see that view. But once again, that tower is fairly new. So they may have used that camera, whatever camera's like right here looking at Dragon, looking that way out to sea. That camera's looking east. If they may have used it on a Starlink mission, but I haven't seen that ever used before, which is sweet. Because, yeah, this is the first time a Dragon 2, albeit a Dragon 2 cargo, is being launched from Pad 40. So that's actually, yeah, super freaking cool. SpaceX, for all intents and purposes, has 2 pads that can launch people now, which is pretty sweet. Where my mind goes from there is, so when's Vandenberg getting a tower? Who knows? Dragon Polar once around? When? No, it's probably not going to happen.
About 50
But it could.
Dragon's nose cone deployment sequence will begin, exposing its guidance
Sun Temple, thank you
navigation
for the
controls that help Dragon autonomously fly to the space station. With T0 coming up in about 12 minutes, our teams at the Cape and Hangar X are doing a series of system checks to ensure Dragon and Falcon 9 are ready to fly. Reusability is key to making spacecraft spaceflight more routine and ultimately what will enable humans to become multiplanetary. Down at Starbase, Texas, we are continuing to build, test, and fly Starship,
show it.
the
Show
world's
it.
most
Show it
powerful
launching.
launch vehicle
You may.
ever developed.
Show it launching, please.
1 week ago today, Starship returned to integrated flight testing with its third launch from Starbase. This flight achieved several milestones and firsts. Super Heavy completed its second full-duration ascent burn, the second successful
Woof.
hot stage separation, a successful flip maneuver, and this time made it through the boost back burn and attempted its first ever landing burn.
Attempted.
Starship executed its first full-duration ascent burn, making it to space and checking off several other test
Oh, that's
objectives,
so
including opening and closing its payload door, aka the PEZ dispenser, and initiating a propellant transfer demonstration, and its first re-entry through the atmosphere. Starship brought never-before-seen live views of this atmospheric re-entry, utilizing the Starlink terminals installed on board to transmit a live, high-definition video signal, even as plasma built around it. Starship's rapid development approach has been the basis for all of SpaceX's major innovative advancements, including on Falcon, Dragon, and Starlink. Testing and learning is essential as we work to build a fully reusable
No, the transfer
transportation
worked out.
system capable of carrying both crew and cargo to Earth orbit to help humanity return to the moon and ultimately to travel
Yeah,
to Mars
95
and
eventually.
beyond. Building
All right, guys, I'm going to run ads here. I always run ads about 10 minutes out. If I run ads, there's a 30-minute cooldown on it. So I do that. So if anybody sees a thumbnail of the rocket launches and click on it, they don't get a freaking pre-roll ad. Now, do I like ads? No. I hate them a lot. But if I have a choice when to run them, we'll do that. But yep, so I'll see you on the other side.
the lunar surface will be ready to help humanity build a sustainable presence on the moon and learn how to live off-world before the next step to Mars. Starship is now getting ready for its fourth test flight. Every launch and mission yields critical data for continuing to improve and pave the way for our future in space, and Flight 4 will continue that journey very soon. For now, I'll send it back over to Gary at JSC.
Gary?
Hey, thanks, Yome. Teams in Houston continue to watch the countdown of NASA's SpaceX CRS-30 mission, and everything's looking good. This will be the fourth launch to the International Space Station in an incredibly busy year. Take a look.
Oh, I will.
2024 has been a busy year for human spaceflight at NASA and traffic aboard the International Space Station, and there are no signs of slowing down. The year kicked off with the third private astronaut mission to the orbiting laboratory. 4 crew members representing 5 nations remained in orbit for 18 days, conducting science and outreach before returning to Earth. Multiple cargo deliveries have already made their way to station. Northrop Grumman's Cygnus cargo spacecraft launched on the SpaceX Falcon 9 for the first time with 4 tons of supplies.
Cygnus.
And the Progress spacecraft launched from Kazakhstan with another 3 tons of supplies a few weeks later. A cadre of 4 spacefarers once again launched from U.S. soil on NASA's SpaceX Crew 8 mission. Their arrival began a 6-month expedition on station and relieved the Crew 7 quartet from their half-year stay aboard, who undocked and splashed down off the coast of Florida shortly after Crew 8's arrival. And around the corner, we're gearing up for the first crewed flight of the Boeing Starliner on a mission to verify the spacecraft for transporting crew to and from the International Space Station and add this vehicle to the American fleet of human-rated spacecraft.
Please do.
While progress continues to be made in low Earth orbit, NASA continues to aim for the moon. The Artemis II crew has been preparing for their critical demonstration flight aboard Orion with training in Houston, Cape Canaveral, and off the coast of San Diego for recovery operations. Their mission, a giant leap to humanity's sustained presence on the lunar surface. And the astronaut corps of capable humans willing to take on these challenges in this busy time has only grown. In the midst of continued science and exploration in low Earth orbit, the latest class of NASA astronaut candidates recently graduated from their initial training and are now eligible for future assignments to the International Space Station and Artemis missions to the moon. These individuals will train alongside astronauts from many nations, continuing scientific discovery, exploration, and inspiration, together for humanity.
Continuing scientific discovery is enabled by missions like today. Dragon's about to bring up 3 tons of cargo, much of which includes scientific hardware and samples. The microgravity environment of the space station not only allows for a unique perspective from which to observe physical and biological phenomenon, but it serves as a test bed for improving technologies and capabilities that can send us farther into the solar system and advance our lives right here on Earth. The science portfolio inside Dragon right now includes all of this, enabled by scientists and engineers who have been working for months, sometimes years, to prepare for this moment, a launch to the International Space Station. Here are some highlights of what's inside Dragon today.
What he said.
SpaceX is set to launch its 30th resupply services mission to the International Space Station, carrying science investigations to further NASA's missions to deep space and benefit life on Earth. A new set of sensors on Astrobee robots will test technology to automate 3D sensing and mapping for future space missions. Researchers will observe photosynthesis in space to support the development of bioregenerative life support systems. A student-developed CubeSat will measure sea ice and wave height to enhance our understanding of climate change impacts. Researchers will test controlled nanoparticle arrangement using electric fields to help improve the efficiency of quantum dot synthesized solar cells. Discover more about all of the science making the journey to the orbiting lab at nasa.gov/ISS-science.
Here at just about T-minus 5 minutes, all systems are currently a go for an on-time liftoff. Strong back retraction will begin shortly, and in preparation for that retraction,
Strong back retract.
you heard that call out, the sequence first
Dragon is in terminal count.
beginning, strong back retraction has begun. You'll see the clamp arms on the second stage just below Dragon beginning to open, and then the strong back will recline away from Falcon 9. That transporter erector, which is that large truss structure to the left of Falcon 9, is what will
Strong
retract
back is retracting.
in preparation for liftoff, and you heard that call out that the strong back is retracting. You can see those clamp arms opening just below Dragon as well.
Okay, there we go. I was gonna say it's.
In just a few seconds, you should see that
might have some
strong
desync.
back recline away from Falcon 9 and Dragon.
Where's the booster landing? Shall this one should be. Hold on. Please hold. Your call is important to us. Please stay on the line. This is a landing zone 1. This is Falcon 9 first stage at 1080.
There you can see the
Sixth flight,
strong back slowly leaning
it's gonna
away
land,
from Falcon 9
4 or
and
5
Dragon.
miles that way.
Over to you, Gary.
Gary?
That's right, after strong back retract, we're still counting down, about to approach 3 minutes 30 seconds to launch. At this time, the fuel and oxidizer inside the first stage are fully fueled. Fuel inside the second stage is already at max capacity, and we're just topping off the liquid oxygen on the second stage, which should wrap up topping about T-minus 2 minutes. Now again, we're green, we're tracking good weather, 90% go. Beautiful skies there at the Kennedy Space Center and Cape Canaveral Space Force Station. Now, for some reason we do not launch today. There is a backup opportunity tomorrow, March 22nd, 4:29 p.m. Eastern.
What was Landing Zone 1 before it was made into a landing pad? Landing Zone 1 and Landing Zone 2 are on the former Launch Complex 13, or LC-13 for short. LC-13 was an Atlas Agena launch pad, and then it served a couple of other different purposes like testing missiles and stuff, if I'm remembering correctly. And then SpaceX took it over, but I think it was 2016. Or no, not 2016. It had to be 2015 because that's when the first landing was. So it was sometime in 2015. Anyway, let's go
We
back.
have a 90% probability of launch today based on weather,
PTO is
and in these last few
90%.
minutes, Falcon 9 is
Good day to
performing
fly.
the final health checks on its primary communications,
Yes.
avionics, and propulsion systems in preparation for flight. We'll have that LOX load call out
2 minutes.
complete here shortly.
What are those buildings in the background? So that is the Spock ULA stores a mobile launcher for Vulcan in there when they're not using it, or Atlas, depending on what they're using. There's ground gas closeout. The SPOC, I forget what the acronym stands for, is the former solid rocket motor assembly facility for the Titan ITL complex, which is what 40 and 41 were. They were used for launching Titan 3s. That building, the SPOC, is where they put the SRBs together, and then the other building on the left is the solid rocket motor assembly facility. Or integration facility, solid rocket motor integration facility. They build the SRBs, and then they move them down to that other building and attach them to a Titan, and then roll the Titans to the pad. 40 and 41 are former Titan 3 launch pads. And it was 40, 41, the SPOC, the SMARF, the integration facility were all part of a much bigger launch complex designed to support Titan 3 operations for the Air Force. But, yeah, that's what those other buildings are. What they're used for now, one is used for ULA storing mobile launchers, and then the solid rocket motor integration facility is where SpaceX checks out payloads for Pad 40. Yeah, it's their clean room.
Our go for launch of Falcon 9 and the CRS-30 mission.
There used to be a 4-bay vehicle assembly building at the southern end of the ITL causeway, but they demolished it. T-minus 20 seconds and counting. 15.
15 seconds.
10.
Minus 10, 9, 8, 7,
Sound suppression water
6,
system is on.
5, 4, 3, 2,
Ignition.
1, ignition, and liftoff at a Dragon return
Spread the wings, Dragon. CRS-30 is in the air. All right.
Tons of science and cargo take flight on NASA's SpaceX 30th Commercial Resupply Services mission. Falcon 9 at 1.7 million pounds of thrust. Pitching downrange, hearing good calls of performance. Nominal trajectory as Falcon 9 and Dragon arc out to the northeast.
30 seconds in, everything looks good. Vehicle is
Falcon
doing
9 has
roll and a
successfully
pitch.
lifted off from Slick 40 at Cape Canaveral Space Force Station. And during ascent, we will tilt or gimbal our engines, guiding the rocket into what we call a gravity turn. Through this turn, the vehicle is flying both up and horizontally away from the launch pad.
So you can see.
Now, this rocket typically needs
You can see the entire ITL causeway here. That's pad 40, that's 41, and they used to build on this side and then send them down to the launch pads. But we got a great ascent
in preparation
here.
for max Q, or maximum aerodynamic pressure, in just a couple seconds.
Max Q.
Great day to fly. Maximum dynamic
There was
pressure
that
on the
call out
vehicle's
for
call.
max Q. And coming up, we have a few events
ISS
in
resupply,
quick
Alberta.
succession, starting with main engine cutoff, followed by stage separation, second
Discovery,
engine
go
start
at throttle
one,
up.
and the start of
There's
the boost back
complex
burn for the
39.
first
That's a
stage.
really steep
MVAC is
pitch
chilling.
over.
There's the call out. The MVAC engine on the second stage is chilling in, getting ready.
So what they just did is started trickling propellants into the second stage to make sure it's at the right operating temperature for ignition, and to make sure that your fuel and oxidizer lines are fully primed for when you go to start it.
From each other, with the first stage making its
Yeah,
way
I'm
back down
watching.
to Earth, and the second stage performing second engine start one, which is where we ignite that single Merlin vacuum engine
Dodo,
on board
tier
the second
299.
stage.
Dankeschön.
Now, the boost back burn will then start on the first stage. This burn helps assist the vehicle
Q
flip
is the
back
math.
around and reorient itself.
Q in math speak is for dynamic pressure. D stands for something else, Beltfed. They ran out of letters. That's the long story short. Okay, there's main engine cutoff.
Miko.
Stage separation confirmed.
Got a good call for stage separation. Upper stage ignition.
MVAC ignition.
And you see the first stage
Stage 1
turning
booster
around,
startup.
starting its engines, coming back to the landing pad. Now we're
There
talking.
you heard and saw those events happening back to back.
Oh.
Awesome views of the first stage flipping back around as it performs its boost back burn.
That's really cool.
Again, we had main engine cutoff of the first stage, stage separation, second
it on home.
engine start start on the second stage, and that first stage doing the awesome flip as it starts its boost back
Both vehicles
burn.
are above the Kármán line right now.
Now this burn is a little under a minute, so we have about 20 seconds left in this burn. And about 3 minutes after that, we will have 2 additional burns on the first stage to prepare to land back at landing zone 1 at Cape Canaveral. We are at T plus 3 minutes and 30 seconds here in today's mission.
This is live broadside.
CRS-30 is SpaceX's.
Stage 1 boost back shutdown.
Boost back shutdown.
There is that confirmation for the boost back shutdown of the first stage
Nominal trajectory.
and a nominal trajectory.
Oh, dude, the
As
track.
again, CRS-30 is SpaceX's 27th launch this year, and we are coming up on the entry burn of the
That's
first stage
awesome.
as well as second engine cutoff.
Dude, that look at where
On
that
those live
stage
views
is.
of the
Someone's
first
tracking
stage, you
that
can
from the
see
ground.
attitude control system creating those beautiful puffs of white
That's like
gas.
70, 80 miles away.
And that's nitrogen from the cold gas thrusters of the attitude control system.
131 kilometers right now on that first stage. That thing's way up there.
And around T plus 6
like
minutes and 30 seconds, you should see on your
380,000
screen the
feet.
first stage's
That's a long
entry
way.
burn.
Someone's
And for
tracking it from the
entry burn,
ground.
We relight 3 of the M1D engines on
That's
the
so
first
cool.
stage, starting with the center engine 9, followed shortly by engines 1 and 5, which slows the vehicle down as it passes back into the Earth's atmosphere. We need to slow down to reduce re-entry forces, which helps us to recover and reuse the
There
first
seems to
stage.
be a roll rate on the first stage. It's spinning. I don't know if you guys
Second
can tell.
stage
Hold
on the right, you can see beautiful views of the Earth in the background, and that Merlin vacuum engine heating up as it performs its burn.
Yeah, that was. Yeah, it got up there, dude, for sure. We are. Yeah.
Again, we
yeah,
are
okay,
a
it
little
did it.
over
Okay,
a
it stopped
minute
it.
to the start of our first stage entry burn.
That roll rate seems a little bit faster than normal,
You can
dude.
see
Maybe
the
they're
first stage
trying
on
a
those
different
live
trajectory
views
or something.
on your
Or I
left
maybe
with
I've never
2
noticed
of
it
the
before
4
because it's all
hypersonic
normal.
grid fins deployed, helping steer that first stage down as it makes its way back home to Earth.
CRS-30, Jack. The payload, Jim World. The payload is the
Now you can see
Dragon
the
capsule.
telemetry on
It's
the
an
bottom
uncrewed
left and
resupply
right
mission to
hands
the
of your
ISS.
screen.
First stage
the
coming
right-hand
back down,
side
getting
is
ready
the
for
second stage carrying our
supersonic
Dragon
retropropulsion.
capsule,
My
and
favorite
the
part.
left-hand side is the first stage. You can see the second stage speeding up as it is performing its burn, and the first stage is coming back down towards the
Yost.
Earth's atmosphere with
Probably
the
like
altitude
60 miles
decreasing.
offshore, if I had to guess.
Really cool views from the attitude control system of the first stage.
All right, watch. This is awesome. Watch it. You're going to see it from the business end. This is fantastic. You'll see that the fire
Just
coming
about
out of
20
Falcon
seconds
forms
from
a
the
heat
start
shield.
of our
It'll look.
first
It'll
stage
be
entry
shaped like
burn.
one. Watch.
We should be able to see really cool views of that burn from those views on the left of your screen.
Oh, there we go. Got a great shot of the Cape. Okay. You should see the RCS fire here for a second in preparation for the burn. Grid fins
Stage
are
1
on.
entry burn startup.
Here we go.
There is the
Oh, come
start
on, give
of
us
the
the track from
stage
the ground.
1 entry
Oh.
burn. And this is a 3-engine burn on the first stage of Falcon 9.
Shut down.
Stage
Grid fins
1
are going to
entry
steer
burn
that.
shutdown.
Steer that
There
sucker
you
in.
Stage
saw-
1 FTS has safed.
Really cool views of the
That
end
smoke
of
coming
the
off of it is
first
them
stage
purging
entry
out.
burn and the
Both
flight
stages nominal trajectory.
It's purging
and
out
the
all the
callouts
oxidizer
for
out
nominal
of the
trajectory
E1
and
and
the
the
flight
E9
termination
engines.
system being
Look at that thing
saved.
fly.
Now the first stage that is
Dude!
supporting today's mission has just performed
That's
its
awesome!
entry burn for the 6th time.
Look
Falcon 9 is the world's first orbital class reusable
look at that
rocket,
thing.
and
It's
this allows
flying.
SpaceX
Falling
to
with
refly
style.
the most expensive parts of the
Bro.
rocket, which in turn drives
Stage 1 transonic.
What?
down the cost of access to space. Now coming up, we have that landing burn starting in just a few moments.
That's freaking rad, dude. There we go.
There's the start of
Stage 1 landing burn.
that
Dude, the
landing
track.
burn.
The track,
Really
man.
cool view of Cape
You've gotta be
Canaveral
kidding me.
Coast.
Stage 1 landing leg deploy.
Hello.
Wow, wonderful
That was awesome.
First stage landing.
Landing confirmed.
Back at landing zone
That's so. I'm
1.
clapping. It's not like they could hear me.
Looking pristine there.
That was
And there
cool,
you have
man.
it.
Guidance.
That landing
Dude.
marks SpaceX's
Did you see it flying
286th
in?
recovery of
That
an
was
orbital
sick.
class rocket, including the first stage landings for Falcon
Stage
9
2 FTS has safed.
and Heavy. You heard that call out that
It is,
stage 2
Jackie.
FTS is
Nice
safe,
uniform.
getting
That's
ready
fine.
for second engine cutoff here in just under 10 seconds.
Jeez. Stand by for Miko. Yeah, it was nice, Lee. They came down nice. Bro, do you even lift? That's so freaking cool, man.
MVAC shutdown.
We were looking for a call for nominal
There
orbit
is that
insertion here.
second engine cutoff with the MVAC shutdown call out, waiting for confirmation of a good orbital
Nominal
insertion.
orbit insertion.
That's the words we want to hear,
There is
chat.
that confirmation of good orbit. It looks like we are on track
that
for
me?
Dragon separation in just a few minutes, just before the T plus 12-minute mark. It has been a great launch so far. As I mentioned earlier, today's launch was the first for our upgraded
Nice.
Dragon to be flying from Slick 40 after we stopped flying the older,
Yeah, many
older
times
version
over.
of Dragon back in 2020.
One of the launches
To
that they
support
showed
our
on the
growing launch manifest, we've made
one of the launches that they showed on the promo reel, NG20. I saw that, and then the mission that preceded that, which was like Starlink 644 or something. Yeah, those are the last two launches I went to. I've seen plenty, dude. I've lost track.
on our way to
I
having
don't keep
2
track of it.
launch pads capable of supporting flying humans to space.
First uncrewed Dragon since
You can
2020
see
from
really cool
Pad
views
40.
of the
Arsenal,
MVAC
from Pad
engine
40.
and the Earth in the background from the second stage. And in addition to flying cargo to support crew on board the space station,
Great
SpaceX
views.
also enables researchers the opportunity to fly critical science to orbit.
It's so cool. I should live closer to go see one. I mean, I don't live near Florida, but yeah, I mean, I still make it a thing. If I lived in Florida, I would watch every single launch. This would be double boxed with me. We'd have the cast right here, and then I'd have a camera looking out at the pad if I lived down there. Oh, boy.
To recap so far, we had an on-time liftoff at
That looks like Long
4:55
Island
p.m.
right there,
Eastern
but-
Time.
Oh, yeah, there I am.
Everything has
There's
proceeded
Massachusetts.
nominally
I
so
see it
far.
over there.
Stage
Long
separation
Island
occurred
right
at about
there.
2.5 minutes into flight,
Nantucket, Martha's
and that was
Vineyard.
followed by
Hey,
a
I'm
successful
in the
landing
picture.
of Falcon
All
9's
right.
first stage at landing zone 1 back in Cape
Yeah,
Canaveral.
that was me.
That was the 6th landing for that particular Falcon 9 first stage. And for those of you following along, this Dragon capsule has also supported CRS-22, CRS-24,
Yeah, I'm in the picture.
and CRS-27,
All right. Right
which were
there.
3 additional
Yeah.
cargo resupply missions
Hi, me.
to the International
hello.
Space Station. At about
That's
T
cool.
plus 8.5 minutes, we had a successful second engine cutoff, followed by confirmation of a good orbital insertion.
You didn't know about blue
The
shifting,
vehicle is
man?
now
Yeah,
coasting with Dragon attached, and
Wait,
we
we
are
can't see you.
just about 30 seconds away from spacecraft separation. We're seeing great views from the second stage with the Earth and the Sun in the background
There's Maine,
as it
but you
prepares
guys are under
to
clouds,
separate
so.
Dragon so that Dragon can begin its journey to the International Space Station.
Purge down right there.
Just a few seconds from payload deployment.
Stand by for Dragon deploy. Dragon separation.
You can see Dragon floating away there.
Thank you for flying.
Very
SpaceX
exciting to
cargo.
see. Dragon is drifting away from Falcon 9 second stage there, confirming good
What is it with
spacecraft
the fat lady
separation.
one? You're obsessed with the fat lady.
As SpaceX is honored to be a part of NASA's Commercial Resupply Services Initiative to deliver critical cargo to the space station. And we thank NASA for entrusting us with today's mission. For those of you following along,
Arsenal,
you'll know
every
that this
flight.
mission marks our 27th of the
What's the
year.
light specs leaving the ship?
Congratulations
Solid
to
oxygen.
the SpaceX team. We're just in March, and we're already launched in partnership with NASA missions like Axiom 3, Cygnus, and PACE, Intuitive Machines, Crew 8, and more.
Cygnus, more like bigness.
You can check SpaceX.com/launches for
That's what
up-to-date
they're doing,
missions
Star
and
Mates.
schedules.
They're delivering snacks.
But that will do it for me here in Hawthorne.
They have so they talk about all the scientific experiments, but there's no way it's 3 tons of scientific experiments. It's got food and water. That's what these resupply missions are. I mean, most of it is swapping out science, but a good deal of it is, well, water. You need that. And fruit snacks. Yep. Fruit snack.
Dragon in orbit and starting its journey on the way to the International Space Station. We're continuing our coverage here in...
What's that, Roadrunners? Question for you on Super Heavy. Do you think they will need to do an orbital entry burn to get through the atmosphere and then do a landing burn like Falcon 9? No. The steel can take the heat, Roadrunner. Think MIG welding versus TIG welding. Yeah. Because Falcon 9 is made out of, I think it's 7000 series aluminum. Actually, it's an aluminum lithium alloy, but yeah, it can't take the heat, so it needs to do the entry burn. Super Heavy, the thing being made out of stainless. Stainless is super dense, so it can take the heat flux. Yeah. Yeah, it shouldn't. Yeah, they don't need to do that. Didn't know about the engines. Raptors should be fine. I mean, the Raptor is rated... I think that's part of the reason why SpaceX rated the Raptor thrust chamber assembly for, like, 300 bar. So, you know, you don't have to worry about stuff like that. If the thing can take a 300 bar explosion inside of it and not break apart, I think it'll be okay, you know.
Food menu items, as well as some crew preference choices.
Yeah, all good, man. You know I'm always here to answer questions.
You're getting a live
That's what I
look
do.
at the second stage, now transferring to the control rooms. On the left side, you
How
see
big are
the
the containers
SpaceX
of
mission
water?
control teams
I don't know
over
off
in
the top of my
Hawthorne,
head, Hellfish.
California, that oversaw today's launch, and
What
will
the
continue to
dog
monitor
do? What the
Dragon on its
dragon
journey
doing?
to the International Space Station over the next day and a half. The teams you see there on the right are here with me in Mission Control Houston, the International Space Station flight control teams monitoring the orbiting complex, and of course the operations jointly with Hawthorne, the flight controllers there. Joint operations between the two teams you see here will come a little bit closer to when Dragon is in its final approach phase, just about 2 hours or so prior to docking. Docking is scheduled for early Saturday morning. Teams here are waiting for the nose cone deploy of Dragon, and we're standing by and continuing our coverage. Now, a little bit about the coming days and what Dragon and the journey that Dragon will undergo. So now that we are past the spacecraft separation from the Falcon 9 and awaiting that nose cone deploy, we're in the activation and rendezvous phase of the mission. During this phase, Dragon is configured for on-orbit operations. The phase begins after separation that we just saw from the Falcon 9 and ends with the completion of the final co-elliptic burn. The initial orbit today is about 190 kilometers by 210 kilometers, those values representing the perigee and apogee of the orbit, or the lowest and highest points over the Earth. Not a perfect circle, more like a very slight ellipse. So over the next day and a half, Dragon will execute a series of burns which will gradually raise its orbit to align more closely with the station. There are 5 major burns where the Draco thrusters on Dragon will fire and bring the spacecraft close to the station before we begin the final approach maneuvers. Let's go ahead and review that now. First is the first major burn, the phase burn. This is performed at the first apogee, or the highest point of the initial orbit, and raises Dragon's perigee, or the lowest point, to a higher altitude. The next burn, which based on the orbital data that we're seeing, is the boost burn, which raises Dragon's orbit until it reaches an altitude just about 10 kilometers lower than the space station. This is followed soon after by the close co-elliptic burn to place Dragon on an orbit that's roughly co-elliptic with the space station. It means the crew, or the Dragon itself, will be about 10 kilometers lower than the station during the entire orbit around the Earth. The fourth maneuver is the transfer burn, where we're raising Dragon's apogee, or the highest point of its orbit, to just 2.5 kilometers below the station. Then we round everything out with what's called a final co-elliptic burn to once again maintain that orbit just beneath the station, but this time on a plane that is 2.5 kilometers below. We did get word that the nose cone is starting to deploy.
That's what I'm waiting for.
This sequence takes just a couple of minutes until it's fully open, and again exposing the forward bulkhead Dracos that will execute the maneuvers you see here on your screen.
Are they picking up the ISS crew? No, this is just delivering supplies.
On the screen will lead us to the approach initiation. This is the final stages of Dragon's rendezvous with the space station and beginning integrated operations with the team here in Mission Control Houston and the teams over in Hawthorne, California.
See, this diagram
During
is
the
always...
approach, the SpaceX...
This diagram is always a little weird, right? Like, it's kind of... You can... I mean, there's no really good way to explain this stuff because orbital mechanics are very weird. But, yeah. And... Oh, yeah, okay. The space station is facing in the right direction. If you're kind of wondering what's going on there, and I'll keep the audio kind of going in the background here. So what this thing does, like with orbital mechanics, like say you have Earth right here, right? And then, please excuse the crudity of this drawing. I didn't have time to build it to scale or to paint it. Say that's the ISS orbit. So what Dragon is going to do... So what Dragon's going to do, it went into a smaller orbit like this, right? And then what Gary's talking about is those are the phasing burns to get it into the right spot. And then it's going to go co-elliptic. So say when the ISS is right here, Dragon is going to put itself, and Dragon's orbit is right here. It's going to put itself into an orbit. It's going to do a burn right here to accelerate. And if you accelerate, you go higher. Right? But the funny thing is, after you're done accelerating, you start to slow down because the Earth's gravity is trying to pull you back. Right? And what Dragon is going to do is it's going to get to a point basically right underneath. I'm talking like maybe a kilometer, like he said 2 kilometers underneath the ISS. When it gets to that point, what it's going to do is, and once again, this drawing is greatly exaggerated, right? This is just to show what's going on. It's going to execute another burn right here, right? And then what it's going to do is over here, you know, that's part 1. And then part 2 down here, when it gets here, it's going to execute a burn to circularize, but get itself out in front of the International Space Station. And then, now, why is it supposed to get it? Why do we want to get out in front of the ISS? Well, if you're looking at they're just showing mission control. The docking ports for Dragon are at the front of the ISS, so you want to get out in front of it. The cool thing is that, you know, the differential motion that you're going to get here. So, like, if this is the ISS, right? Say you got the ISS, there's your solar panels, right? Yeah, I know. It's great. EJ... Wait, what? Oh, say you have the ISS here. The relative motion between Dragon here is when it gets to point 1, Dragon will look like it's coming up like this. Because it is. But it's all relative. So if you were on the ISS, it looks like it's coming up. Right? That would be point 1 right here. So I'm just going to mark 1 and then just put 2 instead. And then when it does this phasing burn, right, what Dragon's going to look like it's doing is this. Right? To get out in front. It's going to do what's called a V-bar alignment. That was the last part. And part 2 is right there. So it's going to look like it comes up and then go out in front, which is actually super cool. What is a V-bar alignment? Well, the station stays localized to the surface. The bottom of the station, or the nadir of the station, is always going to be near the surface, right? And then the top of the station, the zenith, is going to be up. So think about, like, if you have, you know, like if you're a Navy, if you've served in the Navy or know anything about ships, you have bow and stern, right? And then you have port and starboard. Ships spaceships are in 3 dimensions. So you have zenith, which is up, and nadir, which is down, right? So Dragon, when it goes from 1 to 2, is going to do that, what's called a V-bar alignment. So the V-bar is the velocity bar. It's the direction that the station is going. So that would be aligning with the bow, basically. That's the V-bar right there. And then up here, The up-down, the zenith nadir, is the R bar, or the radial alignment. There are 2 docking ports for Dragon to dock to. One is right here, and the other one's right there. So, if Dragon needs to do R bar alignment and keep going all the way up, when it does the second burn here, the second burn is not going to get it out in front. The second burn is going to put it right here. So it's going to do something like this. Right? And what the relative motion, that's actually not the best way to look at it, but that's not the best way to do it. But what that relative motion looks like would be going all the way up and then aligning with that docking port right there, with the radial docking port instead of the velocity docking port. There's always, like, once again, it's a complicated thing to explain. But the graphics, I mean, the graphics are pretty damn good. That's probably the best way to show it, I suppose. But yeah, it's kind of cool looking at the differential motion here. It'll look like Dragon is actually doing circles. If it's doing that R-bar alignment, so like the station is facing this way, you know, Dragon's going to get up to 0.1 here, and then it's going to like look like it's doing circles around the space station, but it's just differential eccentricity. They're just in 2 different types of orbits, and they're kind of falling around each other. And if Dragon's going to do that radial alignment, so up and down, so zenith nadir, right, it'll look like it comes up and then does this, and then goes into its docking port. If it's doing V-bar, it'll go 90 degrees and then that way. It's actually super cool. Did I miss the launch? Yep. You could do it in KSP, yeah. It would be a little bit difficult to get it station orientation constantly right. You'd need persistent rotation to get it done correctly. But anyway, it looks like they got a good confirmation in nose cone deployment. So doing circles without the only with the permission of the station's nadir. Actually, you know, so there's no fly zones around the station, believe it or not. It's called the keep outs. There's 2 of them. There's an approach ellipsoid, which is like a 3-dimensional ellipsis around the space station, and then there's the keep out sphere. So the interesting thing is how spacecraft actually dock to the ISS is depending on where that docking port is, there is a runway, so to speak. There's a corridor or an approach corridor that's lined up with the docking ports. Right? And just like how you'd have like an outer marker or a VOR at an airport, and then you'd have ILS frequencies for different runways, there's the V-bar runway, so to speak, and then there's the R-bar runway. There's 2 approach corridors for Dragon and Starliner spacecraft for the space station. There's 1, 2, 3, 4 for Soyuz in progress on the Russian side of the modules. So basically, Dragon will get up, and once it completes V-bar alignment, it'll enter the approach ellipsoid, right? And then when it gets to the keep out sphere, it'll stop and get cleared for final approach. Final approach is basically when you enter the keep out sphere and dock to the space station. It's just like runways. It's the same idea. There's a corridor, an imaginary like 3D corridor that is lined up with the docking ports, which is super cool. And just like an ILS, just like instrument landing systems on an airplane, Dragon has a sensor on the docking port called Dragon Eye, and it interfaces with it. It's basically ILS for a capsule. And Dragon just does all that automatically. It's pretty cool. Yeah, pretty good stuff. The crazy thing is that Starliner, when it flies in the future, uses what's called a relative navigation system, which means that Starliner has cameras on it, and those cameras are physically looking for the docking ports, and it uses a visual relative navigation system, which is really, really cool. Dragon uses a lidar interface, right? It's homing in on a beacon, just like instrument landing systems on aircraft would home in on a radio signal, right? So Dragon uses a lidar system. The irony here is that Starliner it uses something. It's a visual relative navigation, so they're just using regular visible light spectrum cameras to physically look for the docking port. The irony here is that Starliner's relative navigation system is like Tesla with their full self-driving cars. They're using visible spectrum, not LiDAR, to have the Tesla, like, to work with Tesla's autopilot. Starliner uses something that's more similar to Tesla's autopilot than Dragon would. You'd think it would be the opposite, but it's not. It's very weird. Yeah, hypersonic, everything's good. Yeah, but what if it's foggy around the International Space Station? Mm-hmm. Not to be confused with GoldenEye. Yeah. DragonEye is different than GoldenEye. Yes. Hey, Bloodfam, what's up? When are we racing again? Predominant sent me a clip, and now I got the itch. I don't know. I've been super busy lately. I'm not sure if I have the time, which really sucks. I don't like it. I don't like that, but it is what it is. Narrator, it doesn't get foggy. It's good to see you, though, man. Has there ever been mishaps with docking? Not at the ISS. Well, I don't know. What would you count as a mishap, GG? On Mir, a progress capsule missed the docking port and crashed into a module. Yeah, a progress capsule. It was doing automatic docking, and the abort system didn't work, so the thing just plowed right into it. Hey, MGB, how you doing? It automatically dock-int. Yep. There have been a little bit of weird things with docking. That Progress crashing into Mir, that was 25 years ago. That's probably the closest thing. The shuttle never had any problems with it. But then again, the shuttle was docked manually every time. The shuttle did not have an automatic docking system because it was using a Russian docking port. Not a lot of people know that. Yeah, the shuttle flew its entire career with Buran's docking port in the payload bay. Weird, huh? Wasn't there a Soyuz that slightly missed the port once? Most Soyuz dockings blue have been caught by the crew. So ever since Progress crashed into Mir, the Russians always have the crew on board the station have the ability to override the automatic docking system and then steer the capsule in remote control to the docking port. It's actually really cool. Yeah, really cool safety redundancy there. Yeah, MGB was a great launch. Yeah, Nader, there you go. So there have been modules like Nauka, the Russian science module. They attach that to the space station, and then basically some type of system on board didn't tell Nauka that it was still docked, that it docked to the space station. So the computers on the module thought it was still undocked because I guess they probably missed a flag in the software or something, and it started to rotate the entire space station downwards. Yeah, a little bit of a pucker moment there. That was a couple of years ago. Interesting. Curious why automatic systems sometimes have very glaring failures. Take STS-3 for example. Working the bugs out, Aiden. Yeah, that was scary when the ISS started doing front flips in space. Yeah, it basically flipped it upside down. That's really bad for it, dude. The ISS is not designed to do maneuvers like that, dude. It would be like trying to flip over a skyscraper. Like if you saw the Empire State Building just lift up off the ground. Now, first of all, that would be weird, and then just turned upside down, and yeah, that would be. You'd be like, that's like. That's some Magneto stuff, you know what I mean? Could they use the Canadarm to manhandle a capsule in, or would it be outside the mass capacity? It's not outside the mass capacity. It needs a grapple point, Uncommoner. The arm can't just grab stuff. You need a what's called a grapple fixture. Cygnus has the grapple fixture. Dragon used to with Dragon 1, but it doesn't anymore. Dragon 2 just docks to the space station. I bet you the software guy is not employed anymore. Yep. Mm-hmm. Yeah, Cygnus does that. And then Dream Chaser will do that too. So remember how I said when we were talking about orbital mechanics, how Dragon will kind of stop underneath the ISS first and then boost its orbit so it looks like it's rotating around the space station? If Cygnus is going to the space station, or when Dream Chaser goes to the space station a little bit later this year, those do that, except they don't do that second part. They just stop underneath the space station and do what's called station keeping. They just basically sit there. And you need a little bit of thrusters to basically fly in formation like that. So the thrusters have to constantly be just moving it, burning. Basically, the thrusters have to be pushing down, or else it's going to fall away from the station. So that's called station keeping. They'll fly in formation, and it just kind of flies there until you grab it with the remote manipulator, and then when Cygnus can sense that when it gets grabbed with the RMS, when it does, it just shut the thrusters off, and then you can just take the thing and berth it to the station with the arm. You wouldn't be able to do that with Dragon 2. It doesn't have the grapple fixture. Cargo Dragon has its own docking system on board, Driados. SpaceX, instead of having a specialized cargo capsule and a specialized crew capsule, they built for the second round of commercial resupply contracts, starting with CRS-30. They standardized everything around Dragon 2 to be able to turn the capsules around faster when they're on the ground. You only have one type of capsule. Both capsules have the same heat shield. Both capsules have the same pressure vessel. Both capsules have the same docking system. Yeah, pretty cool. Must be the pigeons again. Yeah, right. Yep. They've been doing that for a while. Can you guys believe that? That's the fourth flight for Dragon serial number C209. Fourth flight for Dragon. For that uncrewed Dragon. Would you take the chance to go to space? If I knew I had a seat to get home, way boost, sure, why not? Brimo wouldn't like it, but you know. Yeah, Brimo would not be happy about that. We'll deal with that later. I'd do it. That'd be fantastic. I would really like to see Earth from orbit. Oh, jeez. I did not get any sleep. I would really like to see Earth from orbit at least once. Just once. Going to the moon would be a stretch goal. Going to Mars would be an extreme stretch goal. I just need to see Earth from space. I want to see that with my own eyes. Just once. Just once. Buy her jewelry when you get home. It'll be fine. Right. If SpaceX had any... I don't even want to say that out loud. So if SpaceX had some problems on a mission, do you think it would screw them financially, or would they be able to recover? I don't think they'll have problems on a mission, Farhan. They're much too preemptive about that. We were talking about that a little bit earlier when I was playing Workers, and we'll go back to playing Workers in a second. I don't think SpaceX will have a problem, dude. And if they do, they'll be able to figure it out. The reason why is because the best. All right, so this goes back to understanding what you made. All right, this is gonna sound weird, and I don't really have a better way to explain this. There's no way to accurately predict exactly, mathematically, how something is going to work. Especially when it comes to aerodynamics. Aerodynamics, we can get a really high fidelity simulation. There's always computational fluid dynamics. But if there was a computer that simulated computational fluid dynamics, so like wind tunnel testing, dynamic testing, whatever, if it simulated at the atomic level, it would melt the computer. There's just no way. We have no way of quantifying how something is going to fly through the air. You have to eventually fly it. That's why we have test aircraft. That's why we have test pilots. You can design a plane. We can design a plane. You can design as many freaking planes as you want. You could build as many planes as you want. You're never going to be absolutely sure how the thing works until you go and fly it. Now, what am I trying to get at? Flying, building something and flying it, rocket, airplane, whatever, that gets expensive very fast. However, flying is the best teacher. That's the best teacher. You will never learn more than sending it. Now, Farhan, what does this have to do with your question? Well, I don't think SpaceX would have a problem. You know why? Because they're preemptive. You know why? They learn a lot. They're always learning and they're always understanding what they made. Right? And what does SpaceX do a lot? Fly a lot. Would you trust a pilot flying an airplane that has 5,000 hours at the seat of that airplane or 100 hours at the seat of that airplane? Right? See what I'm talking about here? Flying a lot is the best teacher. That's the best teacher. And, you know, you shouldn't ever say never, right? Because something like Apollo 13 could happen, right? However, even if something did happen with it, I think SpaceX, due to their insanely high frequency of launches, would be able to solve that problem. They have the chops to be able to fix it. Some of the best minds in aerospace work at that company. I don't think we'd ever run into that. SpaceX is working day and night as hard as they possibly can, you know, succeeding on all fronts: engineering, flying, learning, analysis, simulation, testing, all fronts, 24/7, 365, on how to make that spacecraft be able to get something, or make their systems and make the things that they build able to explore space. The heck, it's right in the name of the company. SpaceX stands for Space Exploration Technologies. The whole purpose of the company is to make spaceflight normal. And let's be real, they have the capital behind them to do that. Not just total, recent hours. That's another good point, Nader. So, Farhan, I don't think they'll... taking this analogy as a personal attack. All right. Get more hours then, you dope. Oh, shoot, man. It's good to see you. So, they're the ones that are doing the flying the most. They have the most experience, Farhan. I don't think anything is going to go wrong. And if it, well, I mean, you should never say never, but if it does, they'll be able to solve it. And how do you solve it? Good understanding of your spacecraft and what it's doing. That's something that NASA did during the Apollo program. And knowing and understanding how the vehicle works saved the Apollo program many times. Because once again, there's no way you can test everything. You can't take everything into account. It's impossible. We don't have the mathematical formulas to predict 100% how something is going to fly. That mathematical formula, it's called the Navier-Stokes equation. Still, no one's been able to figure it out. Yeah, look it up. We can't use math to get an accurate simulation of aerodynamics. It's just too complicated. I'm not saying we couldn't one day. We're humans. We'll figure it out. But yeah, if you could figure out how to solve Navier-Stokes equations, you will make a lot of money. Yeah, Steely-Eyed Missile Man with Apollo is a good example. Apollo 13 is another good example. Apollo 12, Apollo 13. Part of it is having the chops, having the knowledge, having the hours. And SpaceX has a lot of that. Is that due to a random quantum effect? Chronic, I'm not 100% sure. The math is a little bit beyond my repertoire. I play video games, man. I play Kerbal. There's no Navier-Stokes equations in KSP, you know what I'm saying? Yeah, Blood Fam. I think it'll be good, man. It'll be a good time. But Chronic, I think that might have something to do with it. Yeah, electrons like to, electrons are strange, dude. Strange. Very strange. You know, you go and try to look at them and they're like, no, don't look at me! And then they go over there. We still don't know how that happens. Seriously, the simulation is malfunctioning. You go to look at an electron and it's there, and then you go to like focus in on it and it's just whoop, gone, and then it's like over there somewhere. Just pops up over there. They can teleport. We don't know how that happens. That's getting into quantum stuff. It's pretty crazy. There's something called uncertainty principle. Heisenberg. No, not Walter White. Werner Heisenberg. Yeah. Pretty smart. So yeah, it's the uncertainty principle. Mm-hmm. Yeah, interesting stuff, dude. I tried to dive into that once, and I'm like, I don't understand any of this. All right, cool. I'll go back to aerodynamics. Thank you very much. I don't understand what any of this means. These are words. All right, you know. Anyway, I hope you guys enjoyed the CRS-30 launch. We kind of just ended up doing a little impromptu space news after that, huh? Didn't we? I'm not upset. You upset? I'm not upset. Is spin launch still a thing? I think so. I haven't heard anything from them in years at this point. And thinking you will find aerodynamics easier. Aerodynamics are... predictable, I guess. But it's just that. It's a prediction. You never know if it's going to be right. You can kind of take an educated guess with it, but once again, you've got to go fly it. But, yeah, it's pretty, like, I guess the behavior is kind of uniform, you know? But it's a dynamic environment, so it really depends on what you're doing. You might piss air off. You might piss the atmosphere off by doing that whole reentry thing. Starship pissed the atmosphere out the other day, and then the atmosphere ate it. Yeah. Electrons are strange. Rocket Lab might be upset to hear you say that. Yeah. Say my name. You're gosh dang right. I was never good at geography. I always get the numbers mixed up. Yeah, I know how that is. The company I'm really curious to see is Astra. I heard they just went public. No, they went private. They did the opposite of that, which means not. I hope they pull through, you know, because more rockets are better. But instructions unclear. Pissing into wind. Shit. Excuse my language, sorry. I'll time myself out. Okay. Cool. Maybe erudite, I don't know. What would you do without the Blood Fam? I don't know. Have good influences? Shoot. Ha! That's a bibba. Ha! Alright. Do you have a Kerbal control board? No, Yum Food. I just use a joystick and a keyboard. That's it. I do that on purpose, though. Could I sit here and build an entire console out? Yeah. Would I love every second of it? Yeah. Could I wire it? Yes. Would it be amazing? Yes. But I make it a thing to use a keyboard and a very, very simple joystick to play KSP. You don't need some crazy setup to build cool stuff in KSP. Just go and build it. You've aged a lot, Bloodfab. You drink aged whiskey now. Oh, look at you. Pinky out, man. Then do it. No. No, do it. What's the word I'm looking for? No! Anyway. Alright, guys. So, you know what? We'll just switch the title up to space news here. There is some other stuff. EJ's Space and Rocket Review. Let's see, what do we got? This one's coming from Space News. What is this about? Jeff Faust wrote this article. Let's see. Starship could have a big impact on small launch vehicles. Let's see what's going on here. Let's dive into this one. A large launch vehicle could end up having a big effect on the small launch vehicle market through low prices and encouraging customers to build larger satellites. The emergence of SpaceX's Starship vehicle, which is designed to place 100 metric tons or more into low Earth orbit, has captured the attention of companies developing vehicles that can place 1 metric ton or less into orbit because Starship's potential to further reshape a market that was already affected by the company's Falcon 9. Starship for sure will disrupt the future launch business and the space business in general, said Marino Fragnito, Senior Vice President and head of the Vega business unit at Arianespace. All right. Yeah, it's Starship's fault. Yeah, it could. You're right. He's not wrong. Oh, RFA stuff? All right, I got it, Thomas. I mean, I guess not reaching orbit will do the same. Yeah, that's weird. Vega, the last 3 out of 4 Vega launches have not achieved their objectives. But it's Starship, though. Yeah. During a panel at the Satellite 2024 conference March 20th, one scenario is that Musk could really monopolize everything. Well, build a better rocket then. Starship would seem to be ill-suited for launching small sats given its massive size. I think Starship will open new business like exploration, human spaceflight, and commercial space stations. I don't think Starship can launch small satellites or will be used to launch small satellites. So the payload bay door that they tested on IFT-3, what's that for? Starlinks, which are small satellites. Oh, yeah, it's a sunroof. Yeah, well, hey, they opened it and the sun did come out. I'm just saying. What? Does... Is this guy for real? Is this a real person? Is this real life? What do you... Its primary mission is to launch small sats, dude. That's how they're funding the development, by launching Starlink satellites. I mean, I suppose Starlink V2s are not small sats anymore, but also, like, they very... Okay, all right, whatever. Later in the panel, though, he suggested one way Starship could be useful to disrupt the smallsat launch markets by pairing the rocket with orbital transfer vehicles, or OTVs. With Starship, OTVs can become the best option for smallsats. If Starship is able to achieve the very low per kilogram launch prices proposed for it, then it will be difficult for small launch vehicles. I feel like I'm watching John Madden commentate on a football game all again. Well, basically, if you have the player and the player hikes the ball and he throws the ball and the ball goes into the ball's caught by another player and he throws it, it goes into the touchdown. Actually, it's more Chris Collinsworth. All right, we could here. Let me flip it. Not John Madden, Chris Collinsworth. All right, let's switch it up. If you're a football fan. Well, basically, you got a guy, and when he hikes the ball and he throws it, and the other guy goes into the touchdown. Well, guess what? That's what you get. That's when you get a touchdown. Like, okay, I'm a little confused here.
Discovery, go at throttle.
You know, when you have great players playing great football, you're going to get a great football game. It's like, what? Yeah, it's the Will Buxton maneuver. The whole point is to win the race. If you come in first place, you win. Thanks, Will. Thanks, Will. If you don't come in first place, then you won't win. It's like, oh. All right. If you're not first, you're last. Shake and bake. The team with the most points at the end of the game, well, they're the ones that are the winners. You know, like Dead Crew, 42 months. Just remember, great teams that score more points than their opponents tend to win their games. And here, I guess what? The Amazon Web Services has given the team with the most points a 99.3% chance of actually winning when the clock hits 0. Sorry. 99.9 repeating, of course. But anyway, back to this. Starship's capacity and prices, though, could affect the small launch market in other ways by encouraging satellite developers to produce bigger satellites. Such spacecraft, using heavier but less expensive materials, could be faster and cheaper to produce than small satellites. Is this Jeff Faust talking, or is this still the guy? I don't. Starship will open up opportunities for satellites to grow the same way that they shrunk when there were more capacity for small sats. That's actually right. That's correct. Stella Guillen said that, Chief Commercial Officer of ISAR Aerospace, a German company developing the Spectrum small launch vehicle. The industry may shift to launching larger satellites. That's right. That's very good market research. The market did shift, guys. 10 years ago, people were launching 5,000 kilograms. That's 15,000 pound. No, it's more than that. No, it isn't. It's less than that. So they were launching 5, 6, 7 ton satellites into space, and those satellites would go up to GEO. You've seen a huge shift towards small sats with internet satellite constellations like Project Kuiper, Starlink, OneWeb. The they've moved more towards low Earth orbit communication instead of geosynchronous communication. But yeah, I mean, I suppose Starship could change that, but you could make the argument that Starship could, deploy an entire low Earth orbit constellation in one shot. Which, I mean, I got it, T-Man. Thank you. But that's actually right. The trend has gone towards miniaturization over the past couple of years, and it could shift it back. I mean, yeah, it'd be a good idea. I was watching a video. What is that, Leggy? I was watching a video about how Starship would have the ability to deploy large Starlink sats for the purposes of the T-Mobile cell network. The V2 mini satellites that are flying right now on Falcon 9, Leggy, can do that. Yeah. Starlink rolled out direct to cell direct to cell phone usage. That was actually super recent. That was in the past like 2 months. So here's the thing. Here's what makes that it's actually a super smart idea. So a little bit on this. These things use very high frequencies. They use high frequency. When you have high frequencies, right? High frequencies work. They can work over long distance depending on how much power you can transmit. But high frequencies are highly directional signals, right? That's why, so your cell phone really relies on line of sight with a cell tower. That's why if you go inside like a metal building, for instance, right? You don't have line of sight and it's metal. Like, it'll work inside of a house, right? You can bounce a signal off stuff. It's possible. You know, walls will reflect the signal, etc., etc. But cell phone coverage is highly dependent on line of sight. That's very important, right? With that being said, you know, when cell towers are on the ground, you're sometimes not going to have line of sight. However, you have a bunch of satellites orbiting overhead. 20 of them could be in line of sight. And if 20 of them are in line of sight, you know, and they're all sending out phased array signals, right? That's what Starlink satellites do. They have a phased array antenna, which a phased array antenna, basically how that works is you can modulate power on an antenna with multiple tiny little antennas on it. Phased array antenna looks like a dinner plate. Actually, it's flat. It basically looks like a table, right? And you can use power modulation to make the signal highly directional. So couple that with the line of sight that you need from one of these bad boys, and yeah, you can get cell phone coverage anywhere. Like anywhere. Once again, is it going to be good right now? I don't know. It really depends on power. If, you know, Starship moves the Starlink V2s, because right now Falcon is moving V2 minis. They're a smaller version of that. If they move V2s in the full capacity, then, you know, you get more power to the satellite, to those satellites, and you could potentially get like 5 bars in the middle of Yellowstone National Forest, which is pretty damn impressive. The only time that direct to cell wouldn't really work is when you're underground. But then cell signal doesn't really work when you're underground unless there's a repeater anyway, right? So that's the way they talk with the crew in the ships, and the space station is in line of sight to a satellite and then to the space station. Well, that's Tidris Weibus, but yeah. I wasn't aware. I'm more of a taste adventurer than interested in the brewing aspect. Are you okay? Yeah, Finn, with the Starlink V2s, my guess is that the satellites can't modulate. They don't have enough power to be able to make the signal highly directional, right? You need more power so you can modulate the phased array antenna power to be able to be, because once again, it's very dependent on line of sight. Now, all right, here, hold on. Here. Phased array is super freaking cool. It's really, really interesting stuff. So this is how phased array works, all right? Here, this is right off the wiki page, but take a look. So with a phased array, you have a bunch of really, really tiny antennas in an array, like a matrix of antennas, right? And you modulate the power between those antennas. And shifting the power around between these little transmitters can basically make it so you can have an omnidirectional antenna. You can point it in any direction using the electronics, using the electricity, rather than like a satellite dish which needs to be turned and moved in different directions, right? You're swapping mechanical articulation for electrical articulation. That's what the theta angle is there for. So if all antennas are getting equal power, the signal is going to go straight. It's going to go perfectly straight. But if you modulate power between the antennas, you can point it in any direction. And depending on the power, depending on the total power on tap here, right? You could basically make that the degrees of motion of the antenna, right? So like, say You know, with a certain amount of power, you can have it work on like 5-degree increments. With more power, you could have it work on 1-degree increments. And that would be better for cell phone service. Yeah, Leggy, that was a good question. It's really interesting stuff. That's what I mean about modulating the signal. Phased array antennas can do that with radio waves. It's really, dude, it is wild stuff. It's super strange. Like, that's kind of the stuff, that's one of those things where you're like, who the hell thought of this? Like, what the heck were you smoking? This is like some Frank Herbert stuff, like Dune stuff going on here, man. Like, what the heck were you on when you freaking wrote this? Like, how? Like, what the heck? How'd you come up with this? Yeah, they use phased array antennas, actually. One is right near my house. That one right there. They used phased array antennas for missile detection. Yeah. The crazy part is phased array antenna broadcasting the right signal. You can bounce the signal off the Earth's ionosphere, and you can have a radar that won't be in line of sight of something, but will still be able to detect it. That satellite array that I just showed you right there are phased array antennas that are working for over the horizon. Now, this shows what you know, like, that's obviously further out from the horizon, right? But these radars can bounce signals off the top of Earth's atmosphere and back down. It bounces a signal off the ionosphere. Like how if you had a laser pointer pointed at a mirror, it would bounce it. Yeah, that's what these radars do. They're missile detection radars. And they use them nowadays to detect space debris and stuff too, which is actually super cool. I just want to know how satellites can pick up the faint signals from your phone without a giant antenna like Iridium or killing your phone battery. Well, it's really more about the antenna having power. The relays having power. The relays. That's the important part. Your cell phone, once again, you can very high frequency signals. So, you know, if you've like Star Trek, tight band, that's what that means. High frequency signals are very, very line of sight based, right? So when you're dealing with super long distances, like if we're trying to communicate with Mars, a parabolic antenna with the right power settings is a much smarter idea because that's like a shotgun blast of radio signals, right? Your cell phone it can get a signal that's 370 miles that way, no problem. The only thing you'd really have to worry about is diffusion from the atmosphere, right? Because gas diffuses that kind of stuff. Yeah, basically the radio wave can hit things. Like that's not the right way to explain it. Sorry, but you get the idea. But the atmosphere is not too bad. Gases can move through it. Light can move through it pretty easily, right? There is distance to an extent, Blue Flare, but once again, if you get more power through the phased array relay there, it should be able to pick up on it, no problem. Think about it like this. Okay, so this is sound, so it's a little bit different. You know, you have the speaker that's on your phone, right? You got a speaker, right? And you can hear that from a good distance away. But if you have a speaker system in a car, right? You can turn that all the way up. That's more power. You can hear it from further away, right? And then there's like highly directional speakers too. Like if you like going to concerts and stuff to see your favorite musician or whatever, those speakers that are on the stacks, the Marshall stacks, if you're like rock and roll, are very directional speakers. You stand behind them, the sound's going to come out all muffled. They're directional. It kind of works like that, but that's sound, not radio waves. It's different. Long story short, the satellites can hear the cell phones. They can hear them, and they can hone in on its signal. It's good enough, which is, once again, it's wild. It's wild, dude. But it's the power of the relay. If I'm understanding this right, I'm not an expert on this by any means. LRADs. Yeah, that stuff. Yeah, exactly. Mm-hmm. Can those antennas be miniaturized in the same way transistors can be? You've seen how big the Starlink phased array the Starlink phased array is for for receiving Hellfish, sure. You can miniaturize it. You could. I mean, this Starlink antenna is no bigger than like a pizza box. It's pretty crazy considering how far that signal is going. These are good questions. I've learned more about space at 4 hours on this stream than I have in my whole school life. Yeah, that's the whole point. It's like having better speakers and microphones at the same time. Yeah, microphones. Yeah, exactly. You can make a microphone a bigger microphone, and you could pick up more sound. Like we were making fun of the NFL a little bit earlier. Those parabolic mics that they have they look a lot like a radio antenna, right? Those parabolic mics that the guys hold on the sidelines, and you can hear the players talking on the field. That's 50 yards away. Same idea. Bigger microphone, bigger speakers, you can hear it further. But it's also directional. Like, you take that parabolic mic and you turn it that way, you're not going to hear anything. Does TDRS have phased arrays? No. We'll be using a Starlink dish. Yeah, there you go, or not, right? Fighter radars are only a couple feet in diameter max. They have to fit in the nose. All modern ones are phased array. Yep. Don't put your eggs on the nose cone, Nader. It'll cook it. You don't even have to turn it that far. Yeah, it's super high. It's highly directional. But long story short, the satellites can hear. You can hear the cell phones. Oh yeah, sure. I would really be interested to see how they dealt with gas diffusion. That would. I bet you that's like their secret sauce, because it is kind of nuts that it can hear a cell phone from 370 miles away up in the vacuum. That's really cool. And when I say hear a cell phone, like it can receive the signal, right? That's pretty cool. How old is TDRS? The first TDRS launch was in 1983, I think. We did some phased array tests for SBSP last year. Stuff is black. Dude, phased array is nuts. Like, Dino, that's one of those technologies where I'm like, who thought of this? Like, how did you... Because phased array is one of those things that a guy was sitting on his toilet taking a dump, and he's like, how can I get the signal to be omnidirectional? It's one of those things, because that's not like... phased array doesn't strike me as one of those technologies that a bunch of guys, sitting in a room thinking about how to do it came up with. This is like, I slipped I was hanging I slipped on the porcelain. Like, I was hanging a clock or something, and I slipped and nailed my head on the freaking stool. And now, I came up with the flux capacitor, right? Like, it's just one of those things. They're like, how'd you come up with this? Like, where was your mind at when you thought about this? 100% a shower thought. Dude, for sure. For sure. Can you explain, like I'm 5, TDRS, Tracking Data and Relay System? Those are NASA's communications satellites, Leggy. TDRS is used... Okay, so let me put it to you like this. Earth, right here, spherical ball, right? If Johnson Space Center is over here, and the ISS is on the other side of the world, how do you communicate? There's an Earth in the way, right? So NASA has constant connection to the ISS. Mission Control Houston is constantly jacked in to the ISS telemetry, and they can talk to the crew at any time. How do they do that? There's satellites that are out in geosynchronous orbit. So they're 23,500 miles that way. And they're triangulated. So you have your Earth right here. There's one here, there's one here, and there's one there. They form a triangle around the Earth. Right? So one is over the United States. The other two are over like Australia and Europe, basically. There's actually sets of them. There's 3 clusters of 3. And what these things do, they just bounce signals. That's all. They just bounce signals. It's just a big, I'll say mirror, but mirror isn't the right terminology. It's called a relay. NASA shoots a signal at TDRS, it bounces off one TDRS, bounces off another TDRS, and bounces to the ISS. That's how they communicate. That's how they stay in constant communication with it. So is that how the Deep Space Network works? If I got the acronym right? Deep Space Network. So TDRS is for any NASA mission that's below geostationary orbit. So that's low Earth orbit, medium Earth orbit. If you go beyond LEO, or BLEO for short, so like if you go beyond geosynchronous into deep space past the magnetic fields, right? That's when the DSN takes over. The Deep Space Network is 3 sets of ground tracking stations. One is coincidentally in Goldstone, California, right? The US. One is in Madrid, Spain, and the other one is in Canberra, Australia. The Deep Space Network are those big honking antennas that look like something out of GoldenEye, right? They're those ones. Those are the ones that we use to communicate with stuff in deep space. The reason why is, well, first reason, TDRS is facing the wrong way. They're facing towards Earth. So if you go past them, you're going to have a hard time bouncing a signal off of them. Standing behind the speaker, right? Same idea. Second thing, we're communicating with stuff that's out past the heliopause, like Voyager 1 and 2. You need a lot of power to send a signal out there. You need a big freaking antenna. So you're saying the Deep Space Network should be rebuilt with phased array antennas? No, that would be a really bad idea. You'd never communicate with anything. You'd never communicate with anything, dude. Once again, parabolic antennas are like a shotgun blast for... A parabolic antenna transmits a signal in a cone, in a conic shape. So it's like the reverse of a shotgun blast. Depending on your frequency and modulation of power, you can get a theoretical convergence distance with your transmitter. It's weird stuff, dude. This is kind of strange, but that's why every parabolic antenna looks like a bowl. The transmitter is actually up at the top and it transmits towards the bowl. And the transmitter transmits out like a speaker, like sound from a speaker, and it bounces off the dish, and the dish turns that expanding transmission into a converging transmission. That's why it's bowl-shaped. So, depending on power, you have a theoretical convergence distance. And anything that's inside of that theoretical cone, right, you'll get a signal to. Can Molina orbits work for tracking? I've tried it in KSP and it kind of works. For tracking and relay, that's why the Molina orbit was invented, for communications purposes in the Northern Hemisphere. Yeah, that's why the Soviet Union made that. Yes. Actually, if you really want to know, here. If you go to DSN now, eyes.nasa.gov/dsn/dsn.html. Oh, never mind. Don't do that. It's not working right now. Those are all the dishes. Yeah, that would... Yeah, they're performing maintenance. Usually you can see what NASA and everybody else is communicating with. You can see who's using the Deep Space Network. It's all open source. Yeah, there's gigantic honking antennas. These big boys right here, 64 and 70 meter antennas. You can go. Those things are the ones that you need to get to Voyager 1, which is outside of the solar system. So I read somewhere that there's a limit to radio waves, something like 10,000 light years, if I remember correctly, and that the waves basically dissipate. Is that true, or am I making it up? They'll dissipate over time, Sewer Red. Yeah. 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 Yes. That's correct. What is a lightning orbit? A Molina orbit or a lightning orbit is a orbit that has an inclination between like 45 to 90 degrees. It's not a polar orbit, but it's not an equatorial orbit either. Molina orbits are highly eccentric though, with the apogee of the orbit being near geostationary altitude. So we're talking an orbit that has the low point in the southern hemisphere of maybe like 500 miles, right? And then the high point of this orbit at 23,500 miles. The idea with mulling satellites, it's an ingenious solution. So why were mulling satellites, why were lightning orbit satellites invented in the first place? They were invented during the Cold War by the Soviet Union. Most of the Soviet Union is at extremely high latitudes. I don't know if you guys realized it gets cold in Russia because a lot of it is north. Weird, huh? I know, weird concept. So the Soviet Union couldn't rely on satellites that are on Earth's equatorial plane, geostationary. You can't see them. There's an Earth in the way. Like the horizon goes over and you can't look down to it. Now, us in the U.S., we don't have that problem because the U.S. is at a lower latitude, right? Russia is not. So they needed another solution for communications. The country's pretty big. You want to make a phone call to Vladivostok from Moscow, that's a long way away, right? So the idea that they came up with is having a cluster of satellites with a differential longitude of ascending node of every 20 degrees. So the idea is that this inclined orbit with apogee near a geosynchronous altitude, right, would spend most of its time up there, like in the northern hemisphere, and it would very quickly transit the southern hemisphere. If you have those every 20 degrees longitude all the way around and have a couple of them in the same orbit, right, but just spaced out apart from each other, right, it's basically like juggling satellites around. It looks like the satellites are juggling around. You'll always have constant communication. You'll just be relaying between satellites. So like one goes up, comes down, the another one goes up, comes down, another one goes up, comes down, another one goes up, comes down. Yeah, that's what a lightning orbit is. Is it used for communication? Yeah, absolutely. Why? Russia doesn't have good line of sight to the equatorial plane. There's an Earth in the way. Here, I'll show you. So Molina orbits look like this. See? That's what I'm talking about. So if you're in the northern hemisphere, you have line of sight to a bunch of different satellites. See what I'm talking about?
Go at throttle up.
Bad info, Bobby. 13-month resub. Thank you. See all those dots? Those are all the Molina satellites. Just like if you go here and you type TDRS, those are the TDRS satellites. They're in clusters of 3. See? 1, 2, 3. 4. There's another one there. 4, 5, 6. 7, 8, 9. Looks like that. See that guy? I wouldn't worry about that guy. There's 1, 2, and 3. They're not perfectly triangulated, but it's close. And then that coupled with the DSN, there's an antenna here. There's an antenna here. And then there's an antenna right there. They're triangulated. 1, 2, and 3. It's triangulated, so as the Earth spins, you can use that to go that way. You can transmit a signal that way, or you can transmit a signal that way. They're 1/3 of the way around the Earth, give or take. And if you look for Starlink, yeah, see, Starlink. That's Starlink. Pretty cool, huh? Now, keep in mind, this is not real time. This is just an approximation. It's not in real time, but this is good for using it for showing examples. What is that site you're using? Nothing? Nothing? See you tomorrow in class, Miss Vaughn. Seriously, I don't want to kiss of death that site. I don't want to kiss of death that thing. Please, please don't do that. Anyway, yeah, that's that article that we were reading about with Starlink and stuff is pretty funny, dude. Dead already? Oh, damn it. Damn it. I'm gonna get so mad at me. I make sysadmins so angry when I do that. Anyway, They should put satellites with loudspeakers in space and play Queen and Kiss. Remember, I mean, I'm not going to disagree with you. I'm not going to disagree. But remember, sound is just an analogy here. Sound and light work a little bit different from each other. In the vacuum, sound doesn't carry very far because sound is more vibrations than it is like light. Queen, yes. Kiss, no. Thanks for letting us know you have not as good a taste in music as I thought you did. I'm not saying Queen is bad, but you're missing out, Tessa. Is there any news about Odie? No. The thing that we saw from AMSAT DL yesterday was a false alarm. They ended up bouncing a signal off a Russian communications satellite, Cosmos 2251, which is, I think it was 2251, I forget. What is this? Forge. Oh. No. We won't show that on... That's... Wait a minute. Okay, I changed my mind. I don't think there's anything else funnier than a guy submitting an A380 in full kamikaze livery when ANA held a contest to design liveries for their A380 that was set to operate between Tokyo and Honolulu. That's not kamikaze livery. There's no kamikaze livery. That's Pearl Harbor, you moron. Wow. Jesus, tap dancing Christ. Wow! Nice, dude. That's Pearl Harbor livery. Those are not the same thing. Dude. Oh. Oh, God. That one made my head hurt. There's no kamikaze livery. Okay. All right. Context. I'm going to do what that guy didn't. Context. So what is kamikaze? Kamikaze is the Japanese word for divine wind. During the Second World War, Japan was running out of airplanes and ships and anything to fight against the might of the U.S. industrial complex in the Pacific Theater. They needed some type of thing to try and stop the onslaught of just ships. The Japanese would go to sink a ship and 4 more would pop up in its place, right? So they needed to come up with something. So because the Japanese at the time, under the emperor, thought that they were the chosen people, they convinced pilots to basically make a crude cruise missile. And the planes would just be loaded up with fuel and they would fly them into things. Now, here's where this is completely ridiculous. Kamikaze, the whole thing was done out of desperation because we need a game changer. That was their Hail Mary. It didn't work. Right? It didn't work. I mean, it did damage a bunch of ships. Like, yeah. It damaged a bunch of ships. But yeah, there's no livery. They didn't paint the planes with livery. They just said, "Here, get in this plane and go fly into that ship. Here's some sake. Here's your ceremony. Bye." Like, there's no kamikaze livery, which is ridiculous. The divine wind refers to, oh boy. Divine wind refers to, I think it was a Mongol invasion of Japan, and the Mongol army tried to invade the Japanese main islands, and a tsunami took them out. I think that could be wrong. Probably is. Was it the Mongolian invasion? Yeah. That happened twice. So yeah, that's why Japan, Imperial Japan, had a huge chip on their shoulder because in the mid-1800s, Japan was a feudal state, and in less than like 100 years, they went from a feudal state to one of a world superpower. Like, you know, and they're like, oh, every time somebody tried to screw with us, it was divine intervention, right? So that's where they, you know, in Imperial Japanese culture, it was cowardly to surrender. You don't surrender. Surrendering is a wimp's way out. That's a coward's way out. So they didn't surrender. That was their solution. It was like, okay, we're not going to surrender, so you need to fly this airplane into the ship because we ain't going down without a fight. It's kind of honorable in some weird Bushido code, like Code of the Samurai way. Like, I guess I can respect that, but also you killed Americans. I don't like that part. That part's not cool. As an American, I don't appreciate that. Now, interesting postscript to this. So, Japan ended up surrendering August 30th. Well, technically September 2nd, 1945, but they ended up surrendering. You want to know the weird thing? The U.S. was planning an invasion of the Japanese main islands in mid to late 1945. But the reason what got Japan to surrender was the atomic bombs, Hiroshima and Nagasaki, and firebombing in Tokyo. That's another thing nobody talks about, but it's okay, right? So, the U.S. was planning an invasion of Kyushu, the most southernmost Japanese island. They were planning a huge invasion. And it was projected million casualties easy because the Japanese don't surrender. Every man, woman, and child does not surrender. They will fight you. Your only way out is you shooting them or them committing, well, not seppuku, but yeah, or them, you know, committing suicide. It's gross. It's gruesome stuff. If that interests you, there's a book by author Eugene Sledge called With the Old Breed. It's one of my favorite books. If you really want to go and read about that, yeah, I read that book when I was really young. That was probably not a good idea, but doesn't matter. So, the interesting postscript about this is that the U.S. was in late 1945, the U.S. was planning to invade mainland Japan and take it by force. The atomic bombs stopped that from happening. The crazy part about this is that when the dates came for that invasion, which wasn't needed, a tsunami hit Japan. Weird, huh? That's weird. It was on almost the exact dates that the U.S. had planned to invade Kyushu. Yeah, not a lot of people talk about that. That's pretty crazy. Committing unaliveness. Yes, Aqualux. Yes. Yeah, nobody knows about that. That's very strange. Like, we shifted the timelines with the atomic bomb here. Because, yeah, an invasion of Kyushu in a tsunami would have been bad. That would have sucked. It wouldn't have ended well for us. It prevented a lot, Katra, yeah. The less deaths from the atomic bomb. It was a difficult decision, but it was the right decision. And, you know, I get it. People don't like hearing that nowadays, but... Well, of course, you're right. Yeah, duh. Yeah, Tessa, it's crazy, right? Blood Vim, yeah. Yeah, necessary evil. But yeah, that's very strange. You can go look this up. A tsunami hit Japan basically when we were going to invade. It's very weird. That's like, oh, yo, maybe something is up there. Maybe they were onto something. Holy crap. Right? Might have helped if the Army brought surfboards. The Army wasn't really fighting in the Pacific Theater. That was the Marines. Marines are the one that took Iwo Jima and Okinawa and the Solomon Islands and the Marshall Islands and the Philippines and Midway and Wake. That was Marines doing that. not the Army. The Army fought in Europe, mostly. There's an asterisk to that. Yeah, sewer rat. Well, that's why I do what I do to curb that behavior. The Pacific Ocean is quite big. Yeah. EJ, is the U.S. bringing the New Jersey and the Missouri back? No, New Jersey is going into dry dock for maintenance. Jens, I wish. That'd be cool. Our resources were split 90 Europe and about 10 Pacific. Well, yeah, Fish, exactly. Army units did operate in the Pacific Theater, but it was airplanes, Army Air Corps. Well, it wasn't Army Air Corps at the time. After 1940... I think it was after 1942, it was the U.S. Army Air Forces. They renamed it, but everybody still called it the Air Corps. Yeah, it was the AAF, not the AAC. And then in 1947, they spun it off. They spun off the Army Aviation into the Air Force. Let me see. Yeah, this. Oh, that would have been bad. That would have been bad. Yeah, that would have been bad. That would have been bad. Yep. I'm kind of happy that didn't happen. But anyway, yeah. This is not kamikaze livery. Yep. That's wrong. It does look nice though. That's pretty cool. Pretty cool livery. I like the green. The green and the red. The green, red, and yellow actually look pretty rad. But yeah. Yeah, the Zap Brannigan maneuver. It just kept sending waves of men. Knowing the killbots had a kill limit. Yeah, Kyle, that's right. Yes. All the Purple Hearts that have been handed out, there's an asterisk to that, if you really want to know. So, Purple Hearts are the award for anybody in the U.S. Armed Forces that gets wounded in action. Okay? You get a Purple Heart if you were wounded and you survived. It's like if you get shot and you survive, you get a Purple Heart, right? The U.S., they did replenish this, actually, well, more recent, comparatively to like World War II. But for the most part, like, Purple Heart distribution actually isn't documented, like, very well because it's the Army. Like, you know, I'm sure they don't want people snooping on it. But for the most part, every Purple Heart that's been issued over the last 70 years was mostly from leftover stock from the anticipation of that battle that I just showed you. Oh, yeah. Most of them. Yeah, we've replenished the stock once. I think we did it once in the 2000s. Yeah. Yeah, that would have been bad. Invading Japan would have been a very bad idea. Yeah. Whoops. And that's after Korea, Vietnam, and the Gulf twice. Correct. Yeah, that's every single war since World War II. Korea, Vietnam, Desert Storm, Panama, Grenada, anything with the Cold War. You know, I said Desert Storm, global war on terror, everything. Where are all the peasants for the wheat harvest? Vietnam made a number, 58, almost 59,000 Americans, Helsinki. Korea was 53, if I'm remembering right. Yeah, I make it a thing to try and remember this stuff, you know? No, Dreadsorrel, combat, any battle related injury, you get a Purple Heart for. No one really talks about Korea. Dude, Korea is nuts. Korea is crazy. If you, like, you go and read about, like, the front lines and how they shifted, it was ridiculous. And then what MacArthur did at Incheon was, frankly, a stroke of genius. Dude, we were like this close from losing the entire Korean peninsula. Like that close. Dude, I'm talking like the entire North Korean army surrounding Busan at the south end of the peninsula and like getting ready to evacuate off the peninsula entirely. We came that close in 1950. Yeah, and then MacArthur told the Marines to land at Incheon, next to Seoul, and basically split the North Korean army off, and their front collapsed completely. And then from there, their front collapsed completely, and they couldn't support the front because the Marines just went right across the Korean peninsula, right? And then the front moved immediately back, and before they knew it, U.S. forces were on China's doorstep. And then China said, no, and pushed the U.S. back to the 38th parallel. And then it stalemated from there. And guess what? Still a stalemate. North and South Korea are still at war. They're still at war. It is a frozen conflict is what it's called. Yeah, it is a Cold War. Bingo. Yep, that's right, Disgustipated. Mm-hmm. Why does the U.S. keep maintaining these ships if it doesn't intend to use them anymore? Who said they didn't intend to use them anymore, Jens? Who said that? Where'd you get that idea from? They're museums, dude. They're floating museums. MacArthur wanted to nuke Beijing. Yeah, him and Harry Truman kind of got into it a little bit. Yeah, he wanted to nuke Beijing. Yeah, he really wanted to do that. And then Truman said, no, we shouldn't do that. And then MacArthur went to the press saying we should do that. And then Truman fired him. Yeah, funny story. Sewer Rat, yeah, I don't think that would have been a good idea. Yeah, I don't think that would have been smart. Yeah, he wanted to, he wanted to. Whew. I mean, it would have worked, but if it's very clear, if it's one thing I've learned from history, it's very clear that Hiroshima and Nagasaki have a very interesting precedent that you should probably pay attention to so we don't do that again. So, yeah, just probably not do that. Just saying. Yeah, should probably not do that. It's probably not a good idea. Yeah, that's right, Edmana. Yeah, yep. Mm-hmm. A friend of mine who works near the old Virgin Orbit factory sent you these pictures. The factory was sold to some food company and the workers were clearing stuff out. Ah. Cool. Neat. The Soviets absolutely would have responded seriously, including maybe nuking the whole U.S. Army. Yeah, it was pre-Sino-Soviet split. That's right. But King, so from MacArthur's perspective, dude, so if you just think to 1953, the Soviets don't have many nukes. They really don't. Like 2 or 3. The screwed up part of this is that was seen as an acceptable loss. See why we don't use nukes? This is probably a bad idea. The only winning move is not to play. Don't do that. I want to get off Mr. Nuke's wild ride, right? Like, yeah, pretty much, Amanda, right? Yeah, war is a pretty stupid way of settling disputes. Yeah, I'm kind of with you on that one, Conical. Total War's bad. Okay. Hey, Everlast, what's up? Yeah, that's yeah. I'm pretty happy that didn't happen. That would have sucked. Anyway, there's your history lesson for the day. You see how I took that crap post from somebody on the internet and turned it into educational? It's what I do. It's kind of my thing. Like and subscribe for more random World War II history content. Yeah, King, we would have gotten a good foothold, but now you started a war with China. That I mean, the Soviets would have backed them up, no nukes or not. Like that would have been a very bad idea. I mean, yeah, that would have been crazy, dude. The U.S. forces in 1953 weren't what they were in 1945. No way, not even close. If we still had our entire World War II fighting force conscripted and ready to go, then maybe that's a good idea. But war isn't a good idea. Like what chat said. Like that's not. I don't think we should do that. Non-credible defense is leaking again. Yeah. Yeah, I mean, King, like I said, that what Hellfish said is right. Like, it really depends on how much of a licking you want to take. It's doable, but what, like, it's like, think about it like, let's turn it back into rockets. Think about making an SSTO. You want to make an SSTO. You want to make something like Venture Star. Is it possible? Sure. Are there going to be obstacles? Yes. Is it going to be difficult to do? Yes. Would you be better off making a 2-stage rocket? Most likely. Right? Probably a good idea. Yeah, floating. I just, yeah, I mean, it's making me want to play Hearts, dude. Yeah, I don't think that would have been a good idea. BB-62 has officially been replaced on the USN registry. New Jersey is now a nuclear submarine. Ah, there you go. Yeah, it's funny. Modern Japan's founding document, King, their constitution, is called the MacArthur Constitution, and its framework is the U.S. Constitution. That's why us and Japan get along so well. There is some stipulations. It's the export version of our Constitution. But yeah, it's called the MacArthur document. Look it up. It's pretty cool. Just because it can be done doesn't mean it should be done. Yep. Yep. Chat gets popping during the history lessons. Hot damn. Yeah, Dean, people like this stuff. And dudes, like, do I like sitting here talking about, like, theoretics about nuking other countries? Not particularly, but, I mean, I kind of do, but I think it's important to mention it. Like, especially since I was dealt a crap hand, like that crap post that we saw. Like, I was like, you know what? I'm going to make this educational. We're going to learn something today, you know? Yeah, Wargaming streams, let's go. That's pretty much what Hearts of Iron is for, dude. Hearts of Iron is for armchair generaling. That's why I play that game. I think we found a new segment called History Lessons with EJ. Jeez, Tessa, okay. Cope. Also needed our infrastructure deep dives. We can do that too. Am I wrong? I'm not touching that one, man. Makes me want to play that classic DEF CON. Now for the next topic. Have you thought about the Roman Empire today? I do from time to time. Not every day. Maybe once a week. Next up, ancient, and not saying it was aliens, but it was aliens. Speaking of infrastructure, I don't hate that. That's pretty cool. You need a big padded leather chair and a pipe. Yeah, Disgust Video. You remember that show? That show's great. Like, I don't mind that the dude with the crazy hair, Giorgio Tsoukalos. Is that guy's name? Like, all right, man. All right. Jeez. So it all started in the Cincinnati Zoo in 2016. There was a timeline shift. Yeah. But yeah, that's the tsunami thing with Japan. That actually happened. It's kind of scary. That's awesome. It's very cool. The timeline has shifted. Bring back some modern marvels, though. Discustipated, that's what I try to do here on stream, dude. I try to be like old school Discovery Channel, you know? Great compelling and edutainment, you know what I mean? Like, that's the kind of stuff I like to do. I love modern marvels, right? Oh yeah, dude, I grew up on that show. Looking forward to the Neutron launch at Wallops. Yeah, did you see the pad? They got the footings poured for the pad, which is pretty sweet. Typhoons, not tsunamis. Yeah. Have you watched any of the Industry on Paradise? No, I'm not. Or Industry on Parade. No, I'm not sure what that is. A&E Wings. Holy crap, good bites. What a throwback. Could SLS use a Centaur 3 derived upper stage? Sure. Imagine modern Marvel circa 1940. Cool. When are we getting Saturn Shuttle? I mean, Insig, that's basically what Starship is, dude. Maybe put a Starship pad at Wallops one day. Yum Food, I'm not going to sit here and pretend like I wouldn't want that. Like, ICPS is a modified Centaur. No, ICPS is a modified Delta stage. Have you ever been to any rocket launch ever? I saw two rocket launches, sewer rad in January. Starlink, I think it was Starlink 643 and Starlink, and then NG20. Yeah, Geek and I in chat. That guy over there. See that guy over there? That guy. Started rewatching MASH from the beginning. Nice. Wants a Starship pad at Vandenberg. And man, I think that's gonna happen, dude. Slick 6. I have no evidence to support that theory, but I think that's going to happen. It makes sense. I mean, that polar orbit once around. Just saying, you could do that with Starship. I'm not sure if Starship has the cross-range capability of the shuttle, though. But Discovery Wings, man. Yeah, I watched a lot of Discovery Wings. I was kind of bummed when they made it the military channel, but the military channel is actually pretty damn good. That was a pretty good channel. If you could see any rocket launch in history, just like go back in time for a day, which one would you want to watch? Apollo 11. That's an easy one. Apollo 11, dude. Whenever suborbital hop travel becomes a thing, what's going to be the main hindrance on making it a possibility? I don't think anything is 95. If we have the ability to do that, I think that's okay. I'm going to try to answer this as succinctly as possible. The FAA is up SpaceX's tailpipe with mishap reports and permission to launch, etc., right? You know why this stuff takes so long, right? And no, the answer isn't bureaucratic nonsense. The FAA is using SpaceX and the Starship program to come up with the legislative framework for commercial spaceports. Now, what does that mean in plain English? Like, okay, cool. They're basically writing up the framework for point-to-point right now, treating Starship like they would treat an airplane and treating Boca Chica like they would treat any other airport. But the regulatory framework for a spaceport is going to be a little different than some grass field in some guy's backyard where he can land his Cessna, right? A little different. But they're developing the regulatory framework as SpaceX is developing Starship. This is why I've never had a problem with the FAA kind of metering SpaceX's approach, right? because they're using it to figure out like how rockets fit into aviation in the United States, which is cool. That's really cool. Boca Chica is going to take time, but in the future, say SpaceX wants a pad in San Diego or something, like on Coronado Island or something. That, I mean, there's no way that would happen. Just using it as an example, right? Like, say they put a Starship pad on Catalina Island, a freaking Catalina wine mixer, or one of the Channel Islands. The regulatory framework will be there. There's a template for how to do it. So, in the future, it's theoretically possible that a Starship pad could pop up in every freaking city. Well, on the outskirts of every city. Let's put it like that. How'd they get a Starship to Vandenberg? Suborbital hop or fractional orbit? I would use a barge in Mana. That's a lot simpler. You use a barge and tow it through the Panama Canal. Probably be a little bit easier to do it that way. We can't even have supersonic flight because of the noise over the continual U.S. They're never going to let space capsules fly around wherever. We'll say coastal cities, Sig. Call it a day. Same reason why airports have clearance zones, are generally on the edge of cities, and don't have things built too close. Probably even more in generally coastal. Yeah. Sure. Yeah, there's a Sig. I don't know if you know about the X-59. The X-59 is trying to fix that problem. I'll say there's a reason why SpaceX is interested in oil platforms. Yeah, well, that's no secret, Oculus, yeah. Dang it, I want a Starship landing pad in downtown Los Angeles. Yeah, Zeppelin, I'm not finishing reading what you said. That's a little out there. Did you say the FAA comment about Part 450? No, we're not done. This is part number 450. What is this? The FAA's Kevin Coleman at Payload Space Capital event regarding Starship. We're trying to work with them to get them on a different program, if you will, in terms of how we approve their launches going forward. We want to get away from the launch-by-launch approvals and get more into what Part 450 was really designed for, which is an approval of a portfolio of launches. See what I mean? Evolving regulatory framework. So in the future, if SpaceX wants to build another Starship pad somewhere, it'll pop up real quick. See? So a travel plan would be like drive to a coastal area, ride on a boat, get on a rocket lands, get back on a boat, ? Profit? Sure. 95. I mean, if you, okay, so say there's, you take a Starship trip from the Channel Islands in Los Angeles on a suborbital hop to, I don't know, let's just say an oil rig that's kind of near Long Island, right? Or in Long Island Sound or something. Actually, Long Island Sound is probably too close. It would have to be out in the ocean somewhere. Say you did that. How long does a boat take to get to the Channel Islands? Or you fly a helicopter or something, right? Yeah, exactly. Okay. Channel Islands off the coast of France. No. The Los Angeles Channel Islands. Not Los Angeles. Not France. I mean, good. So think about this for a second. It'll take like an hour to get out there. Probably take another hour to board Starship. Right? Starship gets fueled. You can fuel it in under an hour. Send it on a suborbital hop, right? It gets there in 15 minutes. Then you land somewhere. You get off and then you get back. So like getting out, egress, and then getting to where you need to go is another hour. That's 5 hours total. That's still less than an airplane. And then the airplane, the 6-hour flight across the entire U.S. doesn't even include the crap that you have to go through with security and stuff. I mean, they probably will, actually, with Starship, but... But see, it's interesting to think about this. You know what I thought when I was coming up with that explanation is that doesn't make a lot of sense for anything that's shorter than like 3,000 miles or about 5,000 kilometers. A suborbital hop doesn't make any sense for anything shorter than that. Because, yeah, that's compounded. It's going to take about the same amount of time. There's no way Starship will be able to compete with like a 747 or a 777 or an A320 or whatever. Now, it will be able to compete with continental hops. So you guys said, like, you know, Los Angeles to London or something, or Los Angeles to, you know, land in the Channel Islands, right? You know, that is very much competitive. That's a 16-hour flight. Yeticus, bits. Yeah, you could get to Australia in 45 minutes. Yep, across the entire Pacific. That's actually a pretty safe corridor. Taking off in Los Angeles, shoot with a flight azimuth of 270, be in Japan in 45 minutes. Yeah. Edicus, thank you for all the bits. I do appreciate it. But the point that I guess I'm trying to make after I kind of thought about that for a second is that Starship is going to be just like any other form of transportation system. There's going to be trade-offs. You're not going to take a Starship going from like Boston to New York City. That's stupid. I would argue that a train would probably be the best way to do that. An airplane, a 45-minute trip in an airplane in a jetliner that has like a 3,000-mile range is kind of stupid. But anyway. I feel like the question would be profit, though, because suborbital flight isn't cheap as far as I'm aware. It isn't cheap right now, but if you mass produce spacecraft, then yeah. And if they can drop pads down wherever they want because of good regulatory framework, then you're good to go. Just saying. Are you wrong? Yes, actually. Yeah, that's what I'm trying to say. I was just trying to be nice. It's expensive right now, but technology takes time to mature. Jet airplanes were too expensive for anybody to use one to fly around passengers. Does that mean we didn't have jet airplanes? Jet airplanes came about in the early 1940s. When did jet planes start becoming passenger planes? The early 1960s. Sometimes it takes time for technology to mature. I'm okay with being wrong. I don't know about this, hence why it's a question. I know. I answered your question. I answered 2 of your questions, man. I got you. I'm just messing. Well, it depends on technology maturation. NASA refers to this as technology readiness levels, TRLs for short. Not total request live. Be quiet. Oh, I just showed my age. Crap. See last for a Slick 6 update. Something that might make you happy. I've seen that picture before. Yeah. There's an X logo on the former payload changeout area at Slick 6. You old turd. Panta, you looking in the mirror? But yeah. The FAA is establishing regulatory framework for commercial spaceports. That's really cool, man. Like, we live in a really, really awesome time. You know, people say, oh, I'm in the wrong generation. I was born in the wrong generation, and I should have been in 1960, bro. Right now is pretty damn cool. It's pretty cool. Considering that we have unlimited access to information and can, for all intents and purposes, see what it was like to live in the 1960s just by using the internet, right? Like, I don't live in the 1960s, go watch Mad Men or something. Jeez. Yeah, that's right, Joe. Yeah, yep. Yeah, geek. Dude, this is pretty awesome, man. The internet is a pretty cool thing to experience, you know? Just saying. Just putting it out there. The internet is pretty good for my life, and just saying. Yeah, we can get to see all these test launches. Yum Food, you know, like, yeah, exactly, dude. You know, people keep, it's like, okay, hang on. Booting up, explanation. Anyway, you know, as a spaceflight fan, we often like say, well, the Apollo program is like Genesis, right? Like, it's like, when are we going to get back to the Apollo program? When are we going to get back to putting people on the moon? When are we going to get back to putting people on the moon? We need to be like the Apollo program. And heck, even I say that. But the truth of the matter is that no one's ever launched a rocket 96 times in 1 year. SpaceX did that last year. No one's ever done that. One style of rocket, 96 times in 1 year. That's never been done. Now, you know, we all want the Artemis program to succeed. Absolutely. We want to go back to the moon. To rectify the mistake that was made in 1972. Right? Everybody wants that. But also, I think it's important to acknowledge that in some way, shape, and form, we're blazing our own trail that's not exactly like the Apollo program. What Falcon 9 is doing, dude, the 1960s United States space program wishes they had something like this. They wish, but then again, we wish we had the Saturn V, but then again, we kind of do. You know? Just saying. Yo, they wish they had Falcon 9. You wish you did, son. Right? You know, I think that's important to have that perspective, dude. Like, all these test vehicles, like, we're seeing stuff that no one has ever done before in space. That's pretty cool. Without the internet, we'd have to pay EJ to come to our house and play KSP on our PCs. What? Is that how that would work? Are we having LAN parties? I mean, like, I mean, that'd be fun. But LAN is the internet. No. We're not having this discussion. You're saying you don't want to have a LAN party? I mean, split screen with EJ, no screen cheating. God, I hated people that did that.
Discovery, go
I've
and
got
throttle up.
pizza, 4 controllers, and Xbox Connect. Where's the Code Red Mountain Dew? Without Code Red Mountain Dew, it's not a party, dude. Things all day, 11 months. EJ, just wondering if your views are better when you discuss Artemis. If your views are better when you discuss Artemis or play Russian SimCity. Huh? I don't understand things. Yeah, I'll say yes. Jolt. Oh, geek, I remember Jolt. Dude, one time, sophomore year, me and my buddy bought 2 packs of Jolt bubblegum and then did an Ace Ventura and each of us put the whole pack in our freaking mouth and went into English class like dude, it was pretty funny. Yeah, that was a dumb idea. The English teacher was like, we looked like we were tweaking. It was bad. I got sent to the principal's office for that. Oops. And here you are, still drinking Red Bulls. What are you talking about? I'm not addicted to coffee. Hi. Oh no! Yeah, where's those toothpicks at, dog? It was the start of a beautiful addiction. Wait, no. Wait, no. That's not good. Oh, did someone get addicted to drugs? No, jeez. All right, guys. We want to jet back over to workers? I'm ready. Are we ready to harvest? Harvest. I strongly suggest you to harvest. Holy crap, a student came to my class high on an edible when you reported it to the office and they just said, we know. Oh, King. Oh, dude. I wouldn't, you know that meme? I wouldn't tell anybody that I win the lottery, but there would be signs. I wouldn't tell anybody that this person, if a student was baked out of their mind, right? I wouldn't let everybody know in class. Oh, but I would screw with them. If I was the teacher, I would screw with them. I'd be like, and you, student? They'd be like, what? I'd be like, can you solve this problem for us? No. Dude, what? There's a spider over there. Whoa, what? Where? Oh, I'd do that. Yeah, people would, yeah. It would be hilarious. It'd be the funniest thing ever. Yeah, I'd mess with it. Yeah. Dude, there's a spider. There's a spider on here. Oh my God. What? Where, bro? Where? Whoa. I'd do that. Yeah. Does that mean? I don't know. That's probably why I'm not a teacher. Bro, the spider is back. What? I don't know. What if you accidentally unlock their mind, man? Oh, I don't know, man. How is 100% thrust determined for rockets and jet engines? And how does NASA know they're going 100% with RS-25? So how do you know what 100% is? You rate it. You say, I rate this engine 100% of thrust for this engine is rated at 100 kilonewtons. And then when you put it on the test stand, you have a load cell that reads 100 kilonewtons. And then you say it's at 100% thrust. And you look at the settings for the rocket engine. What RPM is the turbo pumps? Oh, 10,000 RPM. That's 100%. Did you get SCRV uploaded? No, Nader. The rocket launches screwed me all up, dude. They screwed me all up. Sorry, it might take a second for me, dude, because it's it's a little bit of a pain in the butt because I have all my craft files on this computer and Discord is on that computer, so it takes a second to move stuff around. There's some OPSEC stuff here because I need to log into my emails, save it as an attachment, send it over there. And I don't like logging into... modus operandis don't log into anything on this computer that you're not willing to show everyone else. Not even when I'm not streaming. Just don't do it because you'll forget, right? And then you'll show your email or something. So, yeah, it's probably a good idea to treat this like a work computer. So that's why it takes a second. So just bear with me. I'll get to it. I recommend a USB thumbstick. Do you think I would be doing that if I had a USB thumbstick readily available? God, you guys are dense. Holy crap. Here it comes. Here it comes. Well, EJ, I think that you should just go down to the store and buy a USB thumbstick. All right, here, I'll just do that right now. Let me just go. Let me just go right now. I can feel it. I can feel it coming. Stop typing. Stop. Don't even bother. Stop it. Don't do it. Don't do it. I can stop. Stop typing. Don't hit that enter key on me, you punk. Anyway, all the Moon 2 typers. Sorry. I was having too much fun. Sorry, I could not resist. Dang it. Anyway.
Discovery, go at throttle.
I'll get it to you, dude. Just, yeah. You give me some time. Give me some time. Hey, Wolf, how are you? Before 30 terabytes of thumbsticks in your P.O. box. Oh, God. Well, EJ, you can order a USB thumbstick for $10. Oh, King, thank you. Thank you for this very, very enlightening and enthralling moment. You contribute a lot of useful statements to my chat and make this a better place to be. I hope you're picking up on my sarcasm, because I'm laying it on real thick. You are a good person, and people say nice things about you. We'll send one over with the tower. Oh, jeez. Now I'm actually gonna have that. So the thing is that, dude, I'll say I'm gonna do it, and then the stream goes for 10 hours, and at the end of the stream, I'm like, and I just go to sleep. Sorry, forget. Hey, I'm not perfect, man. What do you want? But you know what? You know what we are perfect for? Playing workers. The Chernobyl